There we go. Can we all see?
Yeah, it's good.
Okay. Right, excellent. So this is part 4 of this year's BGA FRTOL course. And today we're going to be dealing with the TMG flight. So a few things that might be worth just revising or issues that have come up at this point, which I wanted to raise to start with. So the first one is about MATS call signs, and you'll find that MATS call signs can vary a bit. Their call signs might be radar, director, zone, or approach, and you can find it sometimes on the map or on the FRC, but actually it doesn't matter. Start with the place. And they'll come back and tell you what their actual call sign is, and then you can use that subsequently. Gliding club call signs almost certainly shouldn't be something radio, gliding club radio. It ought to be base or launch point if you're talking to somebody on the ground, because radio implies that they're giving a service, an air ground communication service. And I don't think there are any gliding clubs that actually do that. And they shouldn't want to, because then if they do, all their club members talking to them would need a FRTOL. In the exam, though, you can just use the frequencies you're given, so you won't have to worry about it. A point that came up following last week, and thanks to Matt Wang for this, who's got a very good eye for detail, he points out that if you're given a Class D clearance, although that you've been talking to the air traffic service unit for a while, and they will have previously shortened your call sign, when they give you the clearance, they'll use your full call sign during that clearance, and then you would repeat back using that full call sign. So the clearance will go something like Glider Golf Alpha Bravo Charlie Delta, cleared to cross, Rise Norton, zone, and the rest of it. And when you repeat back, you put your full call sign on the back. And that's just to make sure that when they give a clearance, which is an important thing, they are absolutely sure about which aircraft is getting that clearance, and you're absolutely sure about it. A few other little things. We introduced the concept of what we call, I don't think this is what they call it in Cat 413, but a procedural position report. And you'll need to do that in the test if you're going to take it. So this, if you remember, is the thing that gets used by airplanes flying down airways with a procedural rather than a radar service. And what they're doing is they're saying who they are, where the last fix was and at what time, what their altitude is, and where their next fix is going to be and at what time. So Glider Oscar November, SOAM 15, 3,000 feet, Cambridge 30, means we were at SOAM at time 15, even though it's now time 20. Our altitude is 3,000 feet, and our estimate is Cambridge, estimate for Cambridge, which is the next turning point, is at 30. It's not very useful in real life in a glider. They might not know our next turn point. We almost certainly won't have a good estimate. Certainly if we've got a climb in between here and there, but it's needed for the test. So if in the test, and you'll be given well-defined turning points and distances, if you're asked to report, for example, SOAM, then give a procedural position report when you get there virtually, as we did earlier, and you can make a rough estimate for the next time. Just use a couple of minutes per nautical mile. So you'll know how to do it, but it's one of the things that you won't get to use. In real life, what you do if you're asked to report SOAM, you can give the controller some situational awareness. So you can say, Glider Oscar November, SOAM at 15, which will probably be the same time as it is now, altitude 3,000 feet, tracking northwest, or next turn point, Melton Mowbray. in that particular piece of the world, telling an American where Melton Mowbray is that you're going to Melton Mowbray won't give him much information. So the Northwest thing might be better. Okay, so that's just a couple of real life things. We also talked a little bit about the report north of beam thing. A beam is pretty clear. It's when the place you're talking about is on the wing. North of beam isn't. I happened to be at Cambridge today in their air traffic talking to them about a couple of things, and I asked the controller which of these two things he meant if he said north of beam, and he said he didn't really care. If you wanted to know exactly, he'd give you a particular point. When I asked people, does north of beam mean a beam and slightly to the north or directly north, the majority view was the directly north thing, and that's what I think we mentioned last week. But broadly, according to the controller I was talking to, it means somewhere in this area and not down here or over here. A little reminder about why we're talking to airfields. This is a map I produced of my local area. So this is southern England. We've got Cambridge out here, Cranfield, Sywell, Oxford, and Gloucester. And these are the blue lines are the published instrument approaches, although Oxford's got a couple of extra ones because that was what they were proposing and they didn't actually do it. So if you're going east-west across here, it's quite difficult not to fly through one of those instrument approaches. And that's why we end up talking to people on the radio. And lastly, a little reminder about full calls. In Cat 413, it says that pilots are required to state their flight rules in initial calls for arriving and departing flights and for crossings of Class C, D, and E airspace. You can do it in Class G too, if you find it easier, but what it means is if we're making a call to go into a piece of Class D, we need to tell them whether we want VFR or IFR flight rules. That's important for the exam. If you don't do it in real life, they're going to make an assumption that as a glider you're VFR, so it won't matter very much, but you'll need it for the exam. Right, let's get on to this week. Why are we doing a TMG flight? Well, the prime reason is that this course is for a full FRTOL, full radio license. It's just the same license that you would get if you were going to go on to fly a Boeing, an Airbus or something. So you need to know more than just how to use the radio for a glider in order to pass it. So that's sort of good news and bad news. Good news is that it helps you understand how other people operate because we're teaching you something about how that happens. And if you want to extend your Pod SFCL license, which everybody's going to have in a year or so, year and a half, to include a TMG, that's a fairly easy thing to do and it will be useful. And in fact, it's exactly the same set of concepts and skills that we've been using, but with a few extra things. So it's those extra things that you have to know for the exam. Let's talk a little bit about the differences between VFR power and gliding, because that's a useful conversation, I think. And just before I do it, I'll remind coaches to put a star in front of their name so that Shula can do the breakout groups. Okay, so differences between power and gliding. Powered aeroplanes, more often than we do, they fly to and from airfields with full air traffic control, which might be in controlled airspace. So when they start, they'll do a full radio check, perhaps Cambridge Tower, Golf Bravo, Kilo Mike Alpha, radio check, 125.905. Although with modern radios, there's perhaps rather less need. They'll taxi, which we don't do in a glider, and get a takeoff clearance, and they'll need clearances for both those things at a proper airfield. Our pilots tend to write things down, which on a knee pad, which we don't as glider pilots. So we have to think about workarounds. I've never found a sensible way of having a knee pad in a glider that I'm going cross country in. So I don't tend to write stuff down. They fly level and in straight lines, which is not what we do. They'll often try and get a service from an air traffic service unit for the whole trip. So unlike us, where we will maybe talk to an air traffic unit and then go back to a gliding frequency or then turn the radio off, they will switch between one service unit and another and get at least a basic service. They can only fly IMC if the pilot has an instrument qualification. And by IMC, I mean both in cloud and technical IMC, that is above 3,000 feet within 1,000 feet or 1,500 meters of a cloud. So technically that is IMC, and technically they need an instrument qualification to do it, whereas as a glider pilot, we don't. They have much more regular joining and circuit procedures, and we'll come to those because it's worth understanding what they look like. And then once they've landed, they'll need to taxi and get a clearance for that. So these are somewhat different to what we do. It is possible to fly power VFR just like a glider. So from one farmer strip in Class G to another, without talking to anybody and without a radio. So they can do that, it's just that normally they don't. And the alternative, the opposite end of that, is to go from one piece of Class D to another piece of Class D, and that's much more formal. And the language they'll use is exactly the same as we've been talking about, but maybe what they're asking for is a little different. So this is stuff that is worth understanding because it's what other people do. If you're flying in your TMG and you're dealing with this sort of stuff, it's worth developing a bit of a shorthand to write things down. This is pretty much what I would do. I'll use arrows for climb and descend. Remain outside controlled airspace, abbreviate. I've got a little R with a circle around for report, if somebody says report at. In a clearance, I'll use arrows for the turns, and I'll shorten altitudes as much as I can, and levels as much as I can. So that shorthand is useful to you in order to be able to capture notes as you go. In the test, when as a glider, doing the glider test, you'll be able to write stuff down. So I'd recommend you do have a pen in your hand and use it because then you won't have to remember so much stuff. Okay. Let's talk a little bit about LARS, Lower Airspace Radar Service, which is available to help GA traffic. It's provided by a mix of civil and military airfields. It can provide a basic service or a traffic service, maybe a deconfliction service to IFR aircraft, so very rarely to a glider because we don't generally fly IFR. This is important. It's available within 30 nautical miles of the unit providing it and below flight level 100. And it will give a service to both IFR and VFR traffic. And it's by no means full coverage of the country. We'll see a map in a moment. And one of the issues is that the military providers usually go home at the weekends. And the service level you can get is going to vary according to how busy things are. And ironically, when it's more busy, you're less likely to get a traffic service when you need it. And the fact that they go home at weekends. So we don't usually use that service, but GA pilots do, and you will need to know about it for the test. So if you are given a route by the examiner and it takes you past somewhere that could give you a lower airspace radar service, then you should call and get one. Here's this is a map of a year or so ago. I don't think it's changed very much though. And it shows you where the units are in England at any rate, England and Wales, that can provide a service. And there are some quite big gaps in here. So there's a gap around here, for example, where you can't get a radar service, you can get a non-radar service, but some of these things are quite a long way apart. And you've got the frequencies you would call for that service. If we're thinking about the Class D to Class D example of a journey, this is pretty much the most complex example that we might get. It's built up of building blocks, and we need to understand the building blocks. So let's start. The airfield we're using will have several frequencies. It could have a ground frequency, which controls traffic on the ground. It could have a tower frequency that controls traffic on the runway and in the ATZ. And it could have an approach or radar or zone control, which controls the traffic in the local area. So as an aircraft leaving this airfield, we might talk to 3 different controllers from that airfield. Cambridge Bridge is where I was today. There's 2 of those. It has a tower and either an approach or a radar, but they don't do ground. Cranfield theoretically has a tower and approach frequency, but they do the 2 together. Oxford almost certainly will have at least 2, maybe 3 or 4. So going outbound, we'll need a radio check. We'll need to get the ATIS, which, if you remember, is the Terminal Information Service, which tells you what the weather is and what the runway is and so on, and some other information. So you don't have to ask the controller for that. We'll need to get a taxi clearance, maybe with the ground frequency, and then a departure clearance in Class D with tower. That'll give us some after departure instructions, not the takeoff clearance yet. So it'll use the word departure and not takeoff, and it'll say approved, not cleared. So what's happening here is they're saying, before we get airborne, they're saying, when you get airborne, this is what you should do. And that's your departure clearance. And then you'll ask for takeoff, which means you're ready to go, and you will get a takeoff clearance, and that comes from the tower. After we take off, we'll change frequency to approach or radar or zone, something like that. And once we're out of the ATZ, if there is one, then we'll talk to them. And then when we leave the zone, we'll change to the next en route frequency. So again, it's little building blocks that we need to use to build up the flight. Let's have a look at the first one of those, the taxi clearance. And the taxi clearance is an example of a route clearance. So there is a generic thing called a route clearance, and taxi clearance is a specific example of that. And a route clearance contains a clearance limit and a route. So the clearance limit is how far you are cleared. So we're going to clear you to a certain point, and here's how you should get there. So, for example, taxi holding point November via Tango and November. And holding point November on this map here is this point on the taxiway. And then you can see that taxiway November is here. It says taxi November. And Tango is somewhere else. Can't see it. Oh, here we go.
Left side.
There. Taxiway Tango. So if we were up here and they said taxi holding point November via Tango and November, what it means is we can taxi down taxiway Tango and then taxi along taxiway November, and then we have to stop when we get to holding point November. So that's Bournemouth. Yeah, I've been there, done that. And then we'll get an after departure clearance. And this is the clearance to fly in the Class D around the airfield. And again, it's got a clearance limit and a route. So here we go. Here's an example. After departure, clear to the zone boundary via Stony Cross, not above altitude 2,000 feet, right turnout. So the clearance limit is the zone boundary. That's where we're clear to the zone boundary. This is as far as we can get. The route is via Stony Cross with a right turnout after takeoff. And then they've given us another limit, which is not above altitude 2,000 feet. And once we're outside the zone boundary, they'll put us on our way. We won't then need a clearance if we're VFR, because we're outside their controlled airspace. The takeoff clearance, very important. So you're going to say Golf Charlie Delta ready for departure. Note we say ready for departure, not ready for takeoff. The words takeoff are only used in the granting or acknowledgement of an actual takeoff clearance. They'll say Golf Charlie Delta, runway 26 cleared for takeoff, surface wind, whatever. And then you repeat back the important bits of that, runway 26 cleared for takeoff, Golf Charlie Delta. So exactly the same format as we've seen before. You ask something, they give you a clearance, you repeat the clearance and put your call sign on the end. And the repeats are the runways and the clearances, but not the wind. If we arrive at an airfield in Class D, we're going to need to get the ATIS, so we know what runway they're on, we know what their weather is. Then we're going to start the other way around. We're going to start with either approach or radar or zone, whatever. And then we're going to need to get a VFR clearance into the zone. That might well be based on published visual reporting points. So they will, quite a lot of airfields have particular routes in for VFR traffic with reporting points that you'll say where you are in relation to them on the way in. And they might have published visual approach procedures and lanes. So it's basically a set of instructions as to how to come and land at this airfield. When we get, before we get to the ATZ, they will change us to Tower, who control the ATZ, and then Tower will give us joining instructions. So join downwind, right base, or overhead. The order of these things can vary a bit depending on the local procedures in place. This is broadly true of Cambridge, for example. We're going to need a landing clearance. In order to land, they have to say the words cleared to land. And when we're on the ground, we might get asked to tell them when we're off the runway. So call runway vacated. And once we're off the runway, they might change us to ground, and we then would need a taxi clearance. So same thing as we did taking off, just the other way around. And in some ways, doing this is a whole lot easier than arriving somewhere uncontrolled in the glider where we have to make all the decisions, because you're going to get told exactly what to do and where to go. So the decision-making part of the process is actually quite simple. But you do need good RT, and you need to know where the VRPs are and what the procedures are. And these are all written down in books for the bigger airfields. You need to understand the requirement for different types of airspace and different types of air traffic service units. And this chart might help you. So this you need both for the test and also when you get out there cross country. So the thing to realize is what I've got here is, so this is the service, so on the ground, in the ATZ, in the surrounding area, or the zone if it's a full piece of airspace. And then we can look at different types of service. So we've got full air traffic control, which might be in controlled airspace, for example, Class D, might be in Class G. And then we've got an AFIS or an air ground communication service, or somebody without an air traffic service unit at all. If you're going into Class D, you need a clearance for the whole thing. You can't enter Class D without a clearance, and your clearance step by step is going to get you all the way. If, on the other hand, it's in Class G, you're going to need approval to enter the ATZ, and they can control you on the ground as well. So they can control you while you're in the ATZ and on the ground. It's best to talk to them before that, though. So there's the approach area where it's good to talk. If it's just a flight information service, then in the ATZ, you don't need approval, theoretically, but you do need to be in two-way communication with the ATSU, the Air Traffic Service Unit. So you need to have called them, and they need to have responded, and it must be a response that isn't standby. On the ground, they can control you. So you have to ask for a taxi and be granted approval for taxi. On the other hand, an air ground communication service is you need to talk to them, but they can't control you. We have a more complicated system of air traffic in the UK than almost anywhere else in the world, and this is what it looks like. If there isn't,
can I just ask a question quickly?
Yep.
I'm a bit unclear on what the difference is between a clearance given or declined and an approval given or declined. But it seems to be the same thing. It's not yes or no.
There's a formality about a clearance which is a bit beyond the formality of an approval. So a clearance, you have, other people who know about this can jump in if they want. A clearance is generally into controlled airspace or for landing or something like that, and it's an absolute you must do this. An approval tends to be more general. So you'll get an approval to come into a MATS, for example, and you don't formally need that. And here, for example, it's a bit they're similar is the answer, but there's more formality to a clearance. I think that's my best shot at this one. Chula, if you want to jump in on that, I'm happy to listen.
I can think the only things I can think of are on the ground. So I might ask to taxi somewhere non-standard across the grass, and they might say that's approved.
Yeah. Whereas a clearance is a much more, you're going to get a clearance limit and a route and all those things. So,
or I'll give you one more in the air, which is to leave the frequency for 2 minutes. That would be an approval, not a clearance.
Yeah. Okay. Yeah, I think it's a big. Okay, I think we've got it now because Chula's picked out a couple of good examples. They can approve you to do stuff, but they want to retain the word clearance for the specific things that require clearances. So we use different words for it. Also, you need to repeat back. Here's a difference. You need to repeat back a clearance. You don't need to repeat back an approval.
Oh, okay. All right.
Okay. I hope that helps a bit.
Yeah, I think the repeat back is probably the biggest difference, isn't it?
Yeah, probably. Without NATSU, again, you're best to talk. And we have this thing called Safety Com, which you should know about, 135480, where people can make blind calls at airfields. And this yellow best to talk around here is trying to indicate that you don't want to wait till you get to the boundary of whatever it is before you start talking. You can do that earlier. So quite a complicated little diagram, definitely worth studying before you do the test or before you get flying. Okay, let's talk a little bit about how powered airplanes do circuits. And it's a little different from how we do them as glider pilots. The default, by no means the only way, is a standard overhead join. And a standard overhead join is like this. You'd come in generally 2,000 feet above the airfield, fly over the active threshold with the airfield on the same side as the circuit direction. So if the circuit direction is left, which is the default, then you put the airfield on the left and fly over this threshold. And then you do a descent to circuit height, and that's called the dead side. And the radio call is dead side descending as you cross here and go round. And that lets you sequence with other aircraft and gives you visibility of everything that's happening below you. Then your crosswind, you turn downwind. Unlike gliders, there's now two quite big differences with gliding circuits. One is they don't cut the corner, which we do. They don't have a diagonal leg. And the second is they'll go a lot further downwind than typically we will, because they have this engine thing on the front. And in fact, long final is 4 to 8 miles from the threshold, which is a huge distance. They turn base leg and then final and then land. And then they might report runway vacated. So that's the circuit. Also, you can talk to air traffic and get other sorts of join, a base leg join or a downwind join or a crosswind join. And that says that you're going to join the circuit at those points. So you can come directly in and do a downwind leg. There are disadvantages to doing that to do with being able to see other traffic and know where other traffic is. So it's better done when there's proper air traffic control around or people who can tell you what's going on. If, as a glider pilot, we're trying to land at a place like this, though, we're going to have to do whatever is sensible to fit in with that circuit. So let's go there. So imagine that we're gliding, we've run out of lift, and we decide to go land somewhere with proper air traffic. We're going to ask for that flexibility on the type of join that we do, because we're almost certainly going to be lower than 2,000 feet, so we're not going to do an overhead join. We could join overhead and use the air brakes dead side, but from 2,000 feet, we would probably take quite a lot. We'd be looking for lift for quite a lot longer. So we might need some other sort of join, in which case we should just say so. So you can tell them that we're going to land and request a join and request the type of join that you want. If you're going to enter an ATZ and you want a thermal, then you probably need to do a bit of negotiation. And the RT gets a bit more complex, but you can start talking in proper English. So, for example, I might say, request enter ATZ to thermal. So if I'm getting low, there's an airfield local, I can just ask them if I can come into the ATZ to thermal, and that lets me try and find some lift. I can tell them something like, I may need to land if I can't find a climb, which warns them. Now, you're probably getting in the way at this point if you're low and looking for a thermal. So it's important you know which side the circuit is and whether you're in the way. And typically what I've done in the past is I've told them, look, I'm looking for a climb, or I've got a weak climb. If I get in your way, tell me and I'll land. So it's a bit of a negotiation. And generally people have been very helpful, and I've thermaled right above the threshold of some reasonably large airfields, and everybody's been happy. But that's a consequence of talking to people. So you need to keep a good lookout, listen for other traffic, figure out where it is. Be prepared to land if you're getting in the way. Be very clear about your position and your intentions. So if you do find a climb, tell them you're climbing. Tell them when you're clear of the ATZ. And my recommendation would be that if you've got an airfield with an ATSU but without an ATZ, more or less treat them like they do have one. So talk to them as you get local enough that you would be having to talk to them if they had an ATZ. It's a way of staying friends. You might need to use safety comm if you're at an airfield that doesn't have any sort of air traffic service unit and doesn't have its own discrete frequency. If they won't accept you into the ATZ, you'll probably be told remain clear of the ATZ. And really only air traffic, somebody with air traffic can do that. The other types of service can't instruct you in the ground. They can say that you're not welcome to land, although frankly, if you decide to land as the safest option, that's probably an argument you want to have on the ground. It doesn't happen very often, though. The people I know who aren't keen on having you in an ATZ are the Americans at Milton, Malden, Lakenheath. They will try pretty hard to keep you out. Although if you tell them they're going to land at one of their other sites, they might relent. I've seen that. Okay, so something about how to get into a proper airfield as a glider. And they're usually very, very friendly. Right. What's an RMZ? This is something you need to know about. And there's only two in the country, I think, at the moment, Harden and Scilly Isles. There has been a suggestion that Oxford might get one, but that was rejected. So I haven't seen what they're coming back with yet. So we're not actually very likely to I think, be flying in either of these places, but you need to understand what it is. An RMZ is a radio mandatory zone. So it's a zone in which you must have radio communications, two-way radio communications in order to enter it. But it's a little more complicated than that because there are a set of rules that go along with that. So the rule is that you've got to, like I just said, you've got to have two-way radio comms with hardened radar before entering, and you have to maintain them whilst in the RMZ. You need to use the hardened listening squawk and monitor their rate to use their frequency. But there are some ways of doing it if you're unable to do that. So if you're non-radio, you can telephone and agree before the fly. Maybe not very useful for a glider, I would suspect. Or you can operate according to an LOA, a letter of agreement, if you're operating from a site within the RMZ. So that's an RMZ, that's a radio mandatory zone. And there are also things called TMZs, which are transponder mandatory zones, and they're places where you need to have a transponder. If you don't have a transponder, there's some stuff you have to do. So typically, if you don't have a transponder, you have to make a radio call. If you do have a transponder, you don't need to make the radio call. A few details. For RMZs, and Cat 413 says this, wherever practical, establish comms 15 nautical miles or 5 minutes, whichever is greater. Like the MATS calls, that one's not written for gliders. But give them warning, I think, is the thing. You should tell them whether you're on VFR or IFR on the first call. And in all these things, if you're told stand by, that's not two-way comms. It doesn't count. So that applies to RMZs, TMZs, and airfields. For TMZs, radio call can replace a transponder, but access isn't guaranteed. Okay, so that was the stuff that we thought was worth going through for today. If you haven't found it yet, as you get closer to practicing more, go look up the script rehearser stuff on the website. That's useful. Good way of practicing, and scripts are quite good now. So group work tonight is all about the TMG flight to Cambridge from Sywell. Just a reminder, you use their call sign on the first call. They'll use it the first time when they reply, and you can shorten your call sign only after they've shortened it, and you'll probably end up using yours twice. So that's it. Next week. Yes, let's talk about next week first. Emergencies and VHF direction finding. So it's quite useful to know off by heart the format of the emergency call. It's a bit of a pain. Here it is. Very unlikely if you actually have an emergency that you'll go through this exactly like this. And almost you listen to any YouTube video or recording of somebody making an emergency call, and it's never like this. But for the test, you need to do it. The good news now is that you can have that on a crib sheet, and that crib sheet is on the website. So you can actually use the crib sheet to avoid having to learn it by heart. Which gives us the chance to take any questions.
Okay, so there are no questions that I haven't answered directly, and there was only one of those. So I'll just take this moment to say that if you elect to do the gliding version of the FRTOL test, then the examiner is very likely to ask you a set of questions to test your broader knowledge. So many of the things Paul's talked about tonight, and a few others which I'll list, provide good material for the examiner when they're thinking of questions. So the types of control in inverted commas, radio mandatory zones, transponder zones, safety com, conditional clearances weren't talked about, I don't think, so you could look those up. The types of service, these are things that are, if you're thinking they don't apply to me, they do if you're going to do a test. And Paul, the groups are ready.
Okay, thank you very much. Right, okay, so if everybody's happy, let's go to groups.